All right, so this chapter, they tell me to skip section 3.1, but we're going to go through some of the highlights of it, just because we'll probably use those concepts later on. So we're going to kind of jump around in this section, but we definitely want to hit these words real quick. We want to talk about relative max, relative min, and multiplicity. So we're going to hit those real quick, and then we're going to go to 3.2. And there shouldn't be too much in these two chapters, just little concepts that we're going to be piecing together. So right here, we should be at this page, and it says relative max and relative min. Relative max is the highest point in a particular section of a graph. Therefore, relative minimum is the lowest points in a particular section of a graph. So, do you guys see these graphs right here? Do you see this graph right here? Do you see this? Do you pretend this thing keeps on, like they drew it, and this keeps on going down forever? Does it have a minimum? What does a minimum really mean? A lowest possible point. If this graph keeps on going down forever, does it have a lowest point? So does it have what we would call an absolute minimum? No, because it keeps on going down forever. It goes to what we call infinity. To describe the idea of something going on forever, right? Just like Buzz Lightyear. To infinity and beyond, right? Like, it just keeps on going forever. You can't go beyond infinity. With me? So does this graph have an absolute minimum? No. Because what does it do? Keeps on going forever down. You with me? Does this thing have a absolute maximum? No, this thing just keeps on going. But you see this particular part of the graph, this little section of it. If I just look at between here and here, so where my x is 1 and my x to what, 10? Do you see this section where my x is -1 all the way to x is 10? It's like this little piece right here. Is there a highest point? Yes. Do you see they labeled that for you? That is called a relative maximum. It just means a particular section of the graph, it has a highest point. Do you see right here? If I was talking about the interval from here to all the way here, my relative minimum would be this point right here, where my hand is on the mouse thing. Yes? Because that's the lowest point through all this section. Now, what do you notice about my piece? I can change the piece that I'm referring to. Are you with me? Let's change the piece. Let's only go from x can be 0 to x can be 10. We'll say, so notice now I've cut this section off back here. I'm only talking about from here to here. You with me? Now, what's my relative minimum? It's no longer this point, is it? Because this graph is not allowed to be included. I just cut it off. I said, nope, we're not going to talk about this section. I'm only talking about from here over. You with me? What would be my relative minimum? It'd be somewhere around 7.5. Would be my x. What would be my y? Somewhere around, looks like 60. When you refer to your relative minimum, you are talking about the y. You're talking about the output. Does everybody understand what I just said? I'm not talking about my x. I'm talking about how high or how low a graph goes to. So what would that only refer to is your y value. You with me? Y describes height. How high or how low, kind of. Up and down. You with me? So that's the idea of relative max and relative min. On this graph, Does everybody see that my relative, if I'm talking about this whole thing right here, my relative maximum would happen right here at this, and my relative minimum would happen right here. You with me? So then we're going to skip down. The next page that we need to just be on is 218. And the only word I really want to go over is multiplicity. We kind of already discussed this word last chapter. Last chapter we discussed this when I said if you have x to the second power, remember this? And you had this idea where my vertex fell on what? There's only one root, but there's supposed to be how many? 2. So what did this root have? A multiplicity. It means it happens more than once. You follow what I'm talking about here? Okay? So this guy has a multiplicity. So multiplicity is how many times a particular number is a 0 for a given polynomial function. Do you see this example right here? You see this example right there? This is a cubic function. Do you see that if I actually multiplied this out, which I don't want to do, but if I did multiply it out, it would be like 6 point something x to the third power? So how many roots would this function have to have? It would have to have 3 roots. That's what this tells me. That's the only reason I wanted to show you that. Are you with me? Now, what would make this front bubble 0 if x was what? Because 0 squared is, and 0 times 3.4 would be, and then 0 times anything back here would be, so if x equals 0, in this bubble, that would make it 0, right? Well, what about my second? How many times does that happen? Do you see that little squared right there? So far I see it's happening twice. But then I look at this bubble. What would x be to make that bubble 0? 0. Are you with me? What's 0 times 2? 0. What's 0 times anything that's up here? 0. So do you see that in this bubble, x would also equal 0? How many times is this 0 root happening? 3 times. Remember what I told you. Do you remember this right here? Do you see this little square that happens right there? That says it has this x0 has a multiplicity of 2 already. And then I look at this bubble and I've got another one. So how many multiplicities does 0 have? Multiplicity of 3. And why does that make sense? How many roots should this problem have? 3. How many does it have? It has technically 3. It has one root that happens 3 times. You following me? Don't make that any more than it needs to be. Don't need to understand as to why or what that means. On my graph, you're just going to graph it one time. But understand it takes care of the 3 roots I'm supposed to have. So are you trying to make it 0? Yes, because if I'm talking about roots, remember, if I'm talking about roots, I'm on my x-axis. What you know y is when you're on your x-axis. So that means that my y would be 0, and I want to know what x would get me there when I'm talking about roots. Alright. So that's an idea. So that's the idea of what we need to get through for 3.1. Let's move on to 3.2. Alright, so 3.2. 3.2, if we talk about this, we're talking about polynomial powers. So right here, problem 1, you need to understand, you are talking about, why did they all of a sudden refer to this as p of x now? If they're going to polynomial, yeah, the power is fine. Here's what happens with this. All you need to know is that you're going to have ax to the nth power. This power, if you remember in chapter 2, what was that power always? What did we just finish studying? X to the? No, in the chapter 2, not chapter. Oh. What was x always 2 in the chapter 2 test that we just took? Always x squared, x squared, x squared, x squared, right? Well, now, I told you and I kind of previewed this for you. I said, hey, it doesn't always have to be x cubed or x squared. It can be x to the third, x to the fourth, x to the fifth. And now we're going to talk about those guys. We're going to talk about where we have x to some power, and that's why n is a variable, because it can be any number. Now it can be, 12, Megan, and we're going to be talking about that. So, here's some patterns that we're talking about, and don't get too much involved in this. I don't really particularly love this page, but I get what they're trying to show you. Do you see how everything to the even power? They draw it as a U. I don't really like that, but do you see how it starts up and it ends up? Because this graph right here can actually look like this. That's what we're going to be doing. We're going to be talking about these guys. All I need you to understand right now in this section is, do you see how all of these that are powers to evens, you see this is even right here? This is even right here? What way did this start? Up. What way does it end? In the middle, it can do funky stuff. We'll talk about that funky stuff later on, so I don't need you to worry about that funky stuff right now. That's why they just drew it as U's. But I'd rather preview saying, hey, it could look like this, than go the other way that they're doing it. Does that kind of make sense with me? Okay? So then, notice what happens with these guys, with your odd powers. Even this one. Where did this start? Down, and it ends where? Where did this one start? And it ends? Where did this one start? And it ends? That's called end behavior. We're going to talk about that big time today. If I had, this into the 12th, what do you think that graph is going to look like? Both end up. Something like this. Now, do we know what the middle looks like? No, because all I know is the end power. All that middle stuff is going to be determined by all that other garbage. Right? But I know if n is my, and when I say this, by the way, I'm referring to the highest power. Because you can have something like, is this the power of 1?
Yes.
Is this the power of 3?
Yes.
But do you see the highest power is to the 4th? So what do I know about this graph? It's going to be start up and end up. Yes? Okay. Into the 27th power, what do I know it's going to do? Start down and probably end some way up. What do you think about 2m? What is that really saying when n really equals 2m? N is. Why? She's saying it's going to be even. Anytime you multiply any number, right, especially a positive number, because we're not talking about n being negative yet. Anytime that there's a positive number and I multiply it by 2, I'm going to get some kind of even number, right? It has to be, because it's coming in pairs. What's 1 times 3? Oh, I'm sorry, what's 2 times 3? 6, right? And 2 times 3 is 6, so that's an even number, right? Even though I multiplied it by an odd. So what do I know about this graph? It's going to start up and end up. What do I know about 2 plus 1, or 2m plus 1? What do I know it's going to be? It's going to always be odd, so it's going to look more like that. In behavior is what we're really going to talk about big time. The end behavior of a graph of function is the behavior of the graph as x approaches infinity, as x approaches negative infinity. Okay. Bunch of jargon there that we need to kind of clear up. What does it really mean as x approaches infinity? What is x? This is where we're not doing a great job of understanding. If I'm on an axis, on my coordinate plane, when I talk about x, which direction am I only referring to? Left or right? Are you with me? So as x approaches infinity, which side of the graph am I on? I am on the right side. How do I know that? Because from here over, x is going to infinity, and that's my x. You with me? Or as x approaches negative infinity, I'm referring to when, so let's do it in green here. I'm talking about the left side of the graph, since we're at holiday day. That's just my tutu. Look forward to getting that. Alright. Does that make sense, what we're talking about? As x approaches infinity, or as x approaches negative infinity. Okay, we're going to talk about end behavior. So if you see this example right here, as x goes to positive infinity, as x goes to positive infinity, I look at my graph over here. That would be my red. Let me actually underline that in red. That'll help me. Does everybody see I'm talking about the red part of the graph? So I'm talking about this section over here. What do I know about my y, which really f of x really refers to y? Where's it going? Do you see that this graph is going up forever? So what is my y going to? It's going to infinity. And if I look at my left side of my graph, which is the green part, it's going to negative infinity. Really all it's saying is it's going up, or this is facing down. That's all it's really asking. You with me? Okay. So let's talk about this. This is going to be something we need to make sure we understand, this end behavior graph. Do you remember our function looks like this? A, x, n. A is referring to this right here. What does the odd degree power, what is that referring to? What is this referring to? What is odd degree power function? What is it referring to over here? I already got A, so what is this referring to?
The x.
The n. And this is saying, if my n is odd and my a is, what does it mean to be greater than 0? If I said your bank account is greater than 0, what am I really saying? It's positive. What if I say your bank account is less than 0? So really all I'm saying in this chart is if I have a n that is odd and an a that is positive, here's some characteristics I'm going to know about my graph. If my n is odd and my a is negative, and I'm going to fill in the characteristics that I'm going to know about my graph. Following me? So the book writes it like this. The book says if x goes to infinity, that really means just x is what? As it's going towards the positive side, as I'm going right. So as I'm going to the right. As I'm going to the right, what is my y going to be doing? It's going to be going to infinity. And as my x is going to negative infinity, my, actually put there on there, my y is going to be going to negative infinity. As my x is going to infinity here, my y is going to actually be going to negative infinity. And as my x is going to negative infinity, my y is going to be going to positive infinity. So give me 1 second right here. I'm just using these. If I have 3x to the 5th, if I have 3x to the 5th, do you see my a is what? My a is what? Positive or negative? So I'm going to be on this right here. I'm going to be somewhere in this. Now, how do I know if I'm in this box or if I'm in this box? What do I then need to look at? So I go back to my n. What is my n? It's 5. So I'm going to be in this box right here. Does everybody understand that? You with me? What does it tell me about my graph? It says, as I'm on my right side, I know it's going to be going up. And as I'm on my left side, it's going to be going down. That's all this is saying. That's called the end behavior. I know that my end of my graph is going to be going down, and I know my right side is going to be going up. How did I know that? That's what this chart is telling me. Right side is going positive infinity. What does positive infinity really mean? Up. If I'm talking about y. Positive infinity for y means going up. If I'm talking about positive infinity for x, or negative infinity for x, that means I'm going left, and I'm going to be going down. So as I'm on my left side, I'm going down. As I'm on my right side, I'm going up. Kind of making sense? Okay, what does this say? What if I had this? What do I know is going to happen? Based on that chart. Based on that chart, my a is what? Negative, and my power is, what does it say? As x goes, that means x is positive. That means I'm going to the right. As I'm going right, this graph is going to be going down. So I know this graph right here is going to end going down and start going what? What do you notice about the odds? What do you notice about the odds? Each time, one starts up, the other ends down. If it starts down, then it ends. So do you notice that all odds are going to start and end going different directions? Remember, this is more like a science. We're studying the different parts and going, hey, if I know it's a 5, I at least know that it might be going up and then end going down, or it might be going down and then going up. But I know it's not going to start up and end up. Are you with me on that? Okay? So let's go to this one. What do I know about evens and their positive? As x goes to infinity, my y is going to go to infinity. See if you understand what I just said just a second ago. As x goes to negative infinity, where's my y going to be going to? What did I just tell you about odds? One goes up, one goes down. What did I just tell you about evens? If it starts up, what does it do? So if it goes to, if it's on the right side, it goes up. What am I about my left side? It also has to go up. Evens powers will always start and end the same way. This is called the end behavior. It's looking at the graph. In this one, as x goes to positive infinity, what do you think my y is going to do? What's the only case we haven't done so far? Negative infinity. And as my x goes to negative infinity, sorry, there should be negative infinity here. F of x is going to go to where? Negative infinity. Where? Right here. This one. No, no. That's right. This is my x. This is y. So what this is telling you, this says if you have a positive a and you have x to the 6. So I have a positive and an even. I know my graph on my left side is going to be up. And I know on my right side it's going to be up. I don't know about the middle, but I know my end is going to be facing up, and I know my end is going to be facing up. That's what this is referring to. That says, basically this is saying right here, on the right side of the graph, your y's are getting bigger. On your left side of your graph, your y's are also getting bigger, because it's both going to be facing up. That's what the difference was. Remember, even degrees end the same way that they started. Odd degrees end the opposite the way. That's why this was a infinity, and this one went to negative infinity. Odd again, negative infinity ends up going to positive infinity. But if you look at both evens, infinity, infinity. Negative infinity, negative infinity. Because if it starts down, it ends down. Only if it's a even degree polynomial. So basically what you're telling me is, if I said negative 10 x to the 10th, you can already tell me something about this graph. You know your a is negative. You know your x, or your n, is even. So what can you tell me about the graph? You know it starts facing down, and you know it ends facing down. You don't know about the middle section, but you know it's got to look something like this on the ends. That's why it's called end behavior, where it's going to, like, what it looks like at the end of the graph. We call this the end of the graph because we put the arrows on it saying it continues on forever. The middle section we haven't talked about yet, but we've talked about the end behavior. That's basically the biggest thing from this chapter. So, like this right here. What do you know x to the 6 is going to start? Up. What is my a? 1, which is positive. My power is, so if I go here, right here, isn't this saying a is positive, it's even? I should be in this box, which tells me it should, basically, if we, by the way, if we read this, the one thing I don't like about this graph is, don't we normally read left to right? So shouldn't, actually, to be honest, if I was doing this better, I should have done x as it's going from negative infinity, because that would be my left side of my graph, as it's going, and then x to the right side. So The left side of this graph is up. The right side of this graph is also up. That's all that this end behavior was kind of getting from you. That's all it really needed to get.